So we're making this video on simplifying radicals, and also we might not even get to the intro of imaginary, but simplifying radicals. What the heck is a radical? A radical is a root, okay? And in this section, we're going to focus in on square roots, right? Let's jump right in. So we have this page of notes. Let's all go to our page of notes, and right here it says make a perfect square number list from 1 to 144. The very first perfect square number is 1. The next one is 4. The next one is 9. Does anybody know the next one? 16. Anybody know the next one? 25. That's right. How about the next one? 36. 49. If you're like, what the heck, where's he getting these numbers from? It's simply by squaring a number. If you take 1 and square it, 1 times itself is 1. 2 times 2 is 4. 3 times 3, 4 times 4. 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, and 12 times 12 is 144. Now, of course, this list goes on forever, ... Like you could go 13 times 13, 14 times 14. But this is a list of perfect square numbers from 1 to 144. And usually writing these numbers will help you when you're simplifying square roots. You see, when you do the square root of any one of these numbers, you get a nice, beautiful answer, okay? The square root of 16 is 4. The square root of 81 is 9. The square root of 121 is 11. What does a square root actually ask you? The square root of 16 is really saying what number times itself will give you the answer 16. That would be 4 times 4. What number times 81 will give you, or what number times itself will give you 81? That would be 9, right? So the square root of any one of these is a nice, beautiful answer. What's the square root of 100? What's the square root of 144? What's the square root of 4? What's the square root of 25? What's the square root of 30? Well, 30 you can't really do, right? If you do the square root of 30 on a calculator, you're going to get an irrational decimal. That's a crazy decimal that doesn't repeat, that has no pattern, that continues forever. As a decimal approximation, I could be, well, the square root of 30 is going to be between the square root of 25 and the square root of 36. So that would be roughly like 5.5, right? Más o menos, a decimal approximation. But of course, if we want to be precise, we can't just say approximately 5.5. You want to give a simplified radical expression. So the idea is this. Taking the square root of any one of these perfect square numbers is a beautiful answer. So if you don't have the square root of one of these numbers, rewrite it with multiplication so you could get one of those numbers, okay? Because when you rewrite it with multiplication, you're going to be able to split it. Here's a rule that when you're multiplying two terms and you have the square root on both of them, you could split them to each one of them, and you do the square root of A and then the square root of B, and that would be good. So check this out. Let's say the square root of 20, okay? So right here on the side, square root of 20. So if you have your notebook, you could jot this down. 20 is not a perfect square number, so you want to rewrite it with multiplication to get a perfect square number, okay? So 4 times 5 would work because 4 is a perfect square number. 2 times 10 would not work because 2 is not a perfect square and 10 is not a perfect square. But 20, 4 times 5 is great. That way when you split it, you actually have the square root of a perfect square number. And the square root of 4 is what? 2. So your answer would be 2 square root of 5. So this is why when you take the square root of a non-perfect square number, you rewrite it with multiplication to actually get a perfect square number. So when you split them, you could actually do one of them, okay? Now, if I said, what's the square root of 17? You can't rewrite it with multiplication to get a perfect square number, so that would just stay the same. The square root of 17 is the square root of 17. Like, that's as simple as that radical could get. But like, let's say I had the square root of 32. What could I rewrite that as to get a perfect square number? 4 times 8, right? And it's better to write the perfect square number first and the other one second, but don't write this down, okay? Just watch me do this. If you have the square root of 32 and you rewrite it as 4 times 8 because that's 32, yeah, you're going to be able to split the root and you're going to be able to do the square root of 4. The square root of 4 is 2, but you still have the square root of 8. And the square root of 8 is not a perfect square number, but you could rewrite it with multiplication again as 4 times 2. That way, when you split the root, you could actually do the square root of 4, which is 2. But don't forget about this 2 that comes down. So you have 2 times 2 times the square root of 2, which is really 4 square root of 2. Why did I tell you not to write it down? Because that's a hot mess, right? All you got to really do is when I ask you to simplify the square to 32, instead of going with your first perfect square number, instead of going with, 4 times 8 is 32, instead of that, take a couple of seconds more and think of the biggest perfect square number that you could use. 16, right? So I could take the square root of 32 and I could rewrite that as 16 times 2. That way when I split the root, I could actually do the square root of 16. I'll get 4, and the square root of 2 is going to stay the same, square root of 2. So it's the same answer, just done a whole lot faster. Make sense? Okay, so that is a mini lesson of what we should have learned in Algebra 1. But in reality, that's not really that essential right here because our calculators could do it for us. Check it out. So that last question that we did, the square root of 32, type in that square root button and then type in 32, hit equal, and it will give you the answer for square root of 2. It's a simplified radical. So you're probably thinking, what the heck, then why did you even teach us that? Well, because it's good to know. Sometimes it's even faster than typing it into the calculator. And not only that, you are going to have to simplify radicals that involve variables like x's, y's, a's, b's, and c's. And this calculator doesn't do variables like x's, y's, or a, b's, and c's. But anyway, when it comes to the square root of numbers, you could actually do that on the calculator. So let's move on to this section right here. We already did the square root of 20. Square root of 20 is not a perfect square number, so you rewrite it with multiplication to get a perfect square number, and you could split it, and then you could do it, and there you go. But then again, the calculator will do it for you. Down here is a fact that we need to understand and learn, that the square root could be rewritten as a rational exponent, as the power of 1/2, okay? So a square root could be something to the power of 1/2. You could rewrite it as something to the power of 1/2. Let's go with something ridiculously easy, like let's say the square root of 25, okay? The square root symbol, and you could jot this down in your notes right there, there's some space. The square root symbol, you could rewrite that as the power of something to the 1/2 power. I'm sorry, the something to the 1/2 power, that's what I meant to say. And that something is 25 on the inside. So the square root of 25 could be rewritten as 25 to the 1/2 power. Now, why would we do this? Because you could actually simplify this algebraically. You could rewrite 25. You could rewrite 25, make it look like 5 squared, because 5 squared is the same thing as 25. And you could have the power of 1/2 right here. And when you have a power to a power, I hope we remember from the rules of exponents back in Algebra 1, that a power to a power you multiply, and 2 times half, that is 1. So you'd get the answer 5 to the power of 1, which is just 5. Now, I know you're thinking, why the heck would I want to do all this work if I already know that the square root of 25 is 5? Again, because you're going to have variables involved. So it's important to know this fact that the square root could be rewritten as the power of 1/2. Okay. So let's talk about a couple of those. Let's say you had on the side x to, give me any number you want that's even. Any even number. 8, okay, x to the power of 8. Everybody write that down, and let's do the square root of x to the power of 8. So this, the calculator cannot do. The scientific calculator can't do it. So we need to understand and know that the square root is really to the power of 1/2. It's the same thing. So on the inside, we have x to the 8. And of course, the rule of exponent from Algebra 1, power to a power, multiply. So 8 times half, what's 8 times half? 4, so your answer is x to the 4th. Does that make sense? Okay. So the reality is, when you have the square root of something, some variable to an even power, you're simply going to divide that by 2 and you'll get your final answer. Bless you. So let's go down here to this area and let's do some more of those examples. Like if I said, what is the square root of x to the 16th? Okay. The answer is not x to the 4th. Some people are like, oh, square root of 16 is 4. No, that's not it. Okay. Again, you want to know the fact that the square root is really the power of 1/2. And on the inside, what do we have? We have x to the 16th, okay? And of course, a power to a power multiply. 16 times half, what's half of 16? X to the 8th. Nice and simple. Obviously, this work right here that I'm showing is not really necessary. I'm just showing it so you could understand it right now, since it's the first time you're looking at it, okay? But I could just say, okay, what's the square root of x to the 24th? What's the answer? X to the 12th, right? Simple as that, right? What's the square root of x to the 50th power? That would be x to the 25, right? Make sense? Okay. Now, what happens when we don't have an even exponent? Then it gets kind of funky, right? So let's say I have the square root of x to the, let's say, 17th power. Okay, we already did x to the 16th, and that's easy to do. Over here, we have x to the 17th. We would like an even exponent. So when you don't have an even exponent, you're going to do what we did before. When you don't have what you want, you're going to rewrite it with multiplication to get what you want. So we're going to say x to the 17th. We're going to rewrite that as x to the 16th times 1 more x. Does that make sense? Why would I do that? Because now I could split the root, and I could actually do the square root of x to the 16th, which is what? X to the 8th. And what about the square root of x? That just comes down, and that's your answer, square root of x. So x to the 8th, square root of x would be your final answer right there. Sound good? Let's try another one. Let's say x, the square root of x to the 51 power. Okay, we would like it to be an even exponent, so we're going to rewrite it as what? X to the 50 times x to the 1, and then we're going to split the root, and then you'll be able to have your final answer, which is x to the what? 25 times the square root of x. So it's pretty simple. If you have an even exponent, because the square root becomes a power of 1/2, you simply divide it by 2. X to the 16th, the square root of x to the 16th is x to the 8th. Square root of x 24th is x to the 12th. And if you don't have a perfect square number, not a perfect square number, an even power, just rewrite it with multiplication to get that even power. Then you could actually get that answer, and that just comes down on your answer. So going up here, we have some problems we want to work through. You could type this in the calculator, but we all should know that that answer is 3. What's the answer to number 2? Just x, right? Or x to the 1. The square root of 8 is not a perfect square number. So you could rewrite this as, with multiplication to get a perfect square number, as 4 times 2. That way, when you split the root, you could actually do the square root of 4, which is 2, and the square root of 2 stays. So there's your answer. Or, of course, you could type this into the calculator, and it'll simplify it for you and give you 2 square root of 2. But number 4, the calculator cannot do for you. So what would we have on number 4? You want to rewrite it with multiplication to get an even power. So x squared times 1 more x. Then you could split the root, and you could actually do the square root of x squared. What's the square root of x squared? It's just x. And what about the square root of x? That comes down, and there's your answer. X on the outside, square root of x. So when it's an even power, it's super easy. What's the answer to number 5? X to the 2nd, right? But when it's not an even power, you have to rewrite it with multiplication to get that even power. So x to the 4th times x. Then you could split the root, and then you could actually do, what is the square root of x to the 4th? X squared. And what about the square root of x? That just comes down, square root of x. So there's your final answer, x squared, square root of x. How about number 7? What's the answer there? X cubed, or x to the 3rd. Yep, that's it. How about number 8? That's not an even power, so you're going to rewrite it with multiplication. How are we going to rewrite it? X to the 6 times 1 more x, and then, yeah, you could split the root now, and yes, now you could do the square root of x to the 6th, which is what? X to the 3, and then bring down the square root of x, and there's your answer. Are you getting it? How about number 9? What am I going to rewrite that as? X to the 16 times 1 more x. And then you could split it. And then what is the square root of x to the 16? X to the 8th. And what about the square root of x? That just comes down, and there's your answer. Okay. On these guys, yes, the thought process, especially when I was in high school, the scientific calculators wouldn't simplify this. You would think, okay, 50 is not a perfect square number. I want to rewrite it with multiplication to get a perfect square number. 5 times 10 would be pointless because 5 is not a perfect square, 10 is not a perfect square. 25 times 2 would be the good combo. So when you split those roots, you get 5. Square root of 25 is just 5. And then the square root of 2 just comes down. There's your answer. But it's kind of pointless because the calculator will do this for you, right? So technically, 10 through 13, well, I can't even count. 11, 12, 13, 14, 13, what the heck? Anyways, all these the calculator could do for you. But sometimes I think it's even easier to just do it by hand. But the calculator will do all those for you, okay? So I hope we understand how to simplify square roots. Now, we're going to be solving equations. As a matter of fact, what have we been doing for the past several weeks? We've been graphing quadratics, okay? Parabolas. Quadratics are parabolas. And the second half of Unit 4 is solving quadratics. And right here in between, we're just practicing simplifying square roots. And we're also going to learn about imaginary numbers because those things pop up when solving quadratics. So for example, right here we have an equation. It's a quadratic equation, and we're going to solve this thing. Let's solve this logically. What number times itself, what number squared will give you 9? Okay, so we know that the answer is x equals 3, but it could also be x equals -3, right? Because -3 times itself will also give you 9. So it's both a +3 and a -3, and mathematicians always do shortcuts. Instead of writing it 2 times, like x equals +3 and x equals -3, they're going to write x equals plus or minus 3. That means both, the +3 and the -3. But that's just logically. What we're going to do right now is solve this algebraically. See, algebraically, what's the goal of solving an equation? To get x by itself on one side, okay? And if you want to get rid of something, you do the opposite. And what is the opposite of a square? The opposite of a square is a square root. So you could apply a square root here, and what you do to one side, you do to the other side. And of course, the square root and the square, they undo themselves. So you end up with a nice, beautiful x. X equals. Now, here's the catch. It says it up here on the instructions or on the notes. It says when you apply a square root when solving an equation, you must put a plus or minus symbol on your answer. So I applied a square root, and right here it's a square root of 9. The answer is 3, but I need to put a plus or minus in front of my answer. And that's what provides us the complete answer, x equals both +3 and -3. Make sense? I hope. Okay, so you solve the way you always do, but whenever you do apply a square root, just make sure that you put a plus or minus in front of your answer. So just like before, solving in Algebra 1, you want to get x by itself. You want to get rid of things. How do you get rid of things? You do the opposite. We do to one side, do to the other side. So I want to get x by itself. What do I start doing to get rid of everything on the left side to get x by itself? You could divide by 4, but I would get rid of the -16 first by doing +16, right? Because if you divided everything by 4, you'd have to divide by 4, divide by 4, divide by 4. It's a lot more work to do. It's easier to just add 16 and add 16, and you will get 4x squared equaling 36. And then you get rid of that 4, which is a multiplication of 4 in front of the x squared, by dividing by 4, and you will have x squared equals 9. And now finally, to get rid of that square, you apply a square root. And what you do to one side, you do to the other side. But remember the rule that if you apply a square root, you got to put a plus or minus in front of your answer, 3. And on the left side, yeah, the square root and the square, they're inverse operations which undo themselves. So you just have a nice, beautiful x, no more square root. It's just x equals plus or minus 3. And that means that it could be both positive 3 and negative 3. Moving on. Number 3, I want to get x by itself. What could I get rid of first? You could get rid of this multiplication of 5 by dividing by 5. And what you do to one side, do to the other side. You're going to end up with x minus 3 in parentheses to the second power equaling 4. And then you could get rid of the square by doing the inverse operation of a square, which is a square root. And when you do to one side, do to the other side. But when you apply a square root in an equation, you have to put a plus or minus in front of your answer. So far, we have plus or minus, and we know that the square root of 4 is 2. So we have plus or minus 2 right there. On the left side, the square root gets rid of the square, and you have the binomial x minus 3 left over. So the square and the square root eliminate, you just have an x minus 3. Now you still need to get x by itself. So this is where it gets a little weird, but it's not too weird. You get rid of the minus 3 by doing plus 3. And what you do to one side, do to the other, plus 3. But this is where I would like you to rewrite it instead of thinking of your answers. What do I mean by rewrite? Bring down the equal sign, bring down the x. You now have x by itself. X equals what? You have a positive 3 with a plus or minus 2. Now, what is that really? Well, since I don't have square roots, I could actually continue and do both the plus situation and the minus situation. So I should write this as a 3 plus 2 and also a 3 minus 2. And of course, your two answers are going to be 5 and 1. So there are two answers to this quadratic equation. Now, if you're thinking, why the heck are we doing this now? What does this have to do with parabolas, the other section that we did? Think about it this way, guys. If you wanted to really relate this to the previous section, you could move 20, subtract it, move it to the other side. It would be set equal to 0. And then you could think of it as a parabola in vertex form. The vertex would be positive 3, negative 20 if you were to subtract it, move it over here. It's opening up, it's vertically stretched. But this narrow parabola would cross the x-axis at the location 5 and 1 on the x-axis. But obviously, we're not graphing anymore in this section. We're solving, and we went over square roots because it's necessary to be able to take square roots when solving equations. Number 4, what do I do to get rid of everything except for x? Subtract 10. Subtract 10. I have 3 parentheses x plus 1 squared equals 27. What do I do next? You divide by 3. Divide by 3. You now have x plus 1 squared equals 9. And then what? Square root. What you do to one side, do to the other. But when you apply square root, what do you need to put in front of your answer? Plus or minus, right? So square root of 9 is 3, but you put a plus or minus. And on the left side, you just have an x plus 1 left over. No more square root, no more square, just the x plus 1. You still need to solve it. Get rid of that 1 by subtracting 1. We do to one side, do to the other. What I would like you to do is rewrite it. X is all by itself. On the right side, you have the negative 1 with a plus or minus 3. And that will give you two answers. Negative 1 plus 3, that'll give you 2. And also negative 1 minus 3, that'll give you negative 4. So those are your two answers. If you were to have subtract 37, and you could look at this in vertex form where your A is 3, your H and your K, you could graph it. It would be opening up, vertically stretched by 3. It would cross the x-axis at 2 and negative 4. Moving on to the last one here. You want to get rid of that 10, subtract 10, subtract 10. You're going to end up with 2 parentheses x plus 1 close parentheses squared equals 64. What do I do next? Divide by 2, divide by 2. You're going to have an x plus 1 squared equals 32. Final step, square root, square root. Now, square root of 32, 32 is not a perfect square number, so you're going to have to type it in the calculator, or you're going to have to do it on the side right here the way I am. Square root of 32 is not a perfect square number, but you could rewrite it with multiplication to get a perfect square number. That would be 16 times 2. That way, when you split the root, you could actually do the square root of 16. The square root of 16 is 4, and the square root of 2 just comes down. So I'm going to replace the square root of 32 with 4 square root of 2. So what I really have here is my equal sign that comes down. On the left side, I have x plus 1. And on the right side, I do have a plus or minus in front of my answer. Whenever you apply a square root in an equation, you have to put a plus or minus in front of the answer. And the answer is 4 square root of 2. So what we really have is plus or minus 4 square root of 2. But x is not by itself. You have to subtract 1 and subtract 1. So you're just going to rewrite it, and that will be your final answer. You're going to have x equals negative 1 plus or minus 4 square root of 2. Now, you cannot split this up and do it in two situations because you can't really add a number with radicals. You could add radicals with radicals, but not numbers with radicals. So you would leave this as your final answer right here. Anyway, we're going to be working with this all week. And I might as well do this little introduction of imaginary numbers. Check it out. We all know that the square root of 9 is 3. So the square root of 9 is 3. Why? Because 3 times itself will give you 9. But if I asked you for the square root of negative 9, what would that answer be? It's not negative 3, because negative 3 times negative 3 is also positive 9, not negative 9. And it's not positive 3. So in other words, there's no real answer here, but there's an imaginary answer. What we have to do, and you don't have to learn this today, I just want to give you a little taste, that the square root of negative 1 becomes the variable I. That means imaginary. So the square root of negative 9 is really negative 1 times 9. That way you split the root, and you'll have I times the square root of 9, which is 3. And I times 3 is the same thing as 3 times x. That would be 3x, in this case, 3i. So the square root of negative 9 is actually 3i. So that's the only difference, that if you have a negative inside the square root, that negative is going to come out as the variable I. So if I were to say, let me see. Oh, we already did that one. The square root of negative 25, what's the answer there? Okay, once again, anytime you have a negative sign that's going to come out as I, think about this. I could rewrite this as negative 1 times 25, and then I could split the root. And we should know that the square root of negative 1 is I. So the square root of negative 1 is I, and the square root of 25 is 5. And I times 5, that's just 5i. You don't really have to do that work because it's as simple as this. The square root of 25 is 5, and that negative becomes an I, so 5i is your answer. How about this guy? The square root of negative 49, what's the answer there? 7i, right? Because the square root of 49 is 7. That negative sign just comes out as an I. How about this guy? It's a trick question. That is not 6i. That answer is simply negative 6. What? The square root of 36? 6. What about the negative? Put it in the front. So it's just negative 6. Make sense? Okay. We'll pick this up tomorrow.